Intramolecular aldol condensation. We learnt about condensation between two aldehydes or ketones, or one aldehyde and one ketone in the presence of dilute base. Means we know aldehydes and ketones having alpha hydrogen atom undergo condensation in the presence of dilute base. Now what we are learning, condensation within the molecule, that is intramolecular. Then which type of molecules undergo intramolecular aldol condensation? Compounds containing more than one carbonyl group. Means it may be two aldehydes or two ketones, one aldehyde and one ketone, and these two carbonyl groups should be at 1,6 or 1,7 positions with respect to each other and should contain alpha hydrogen atom. When such compounds are treated with dilute base, they undergo aldol condensation in intramolecular fashion to give cyclic products. This is intramolecular aldol condensation. Again I am repeating, compounds containing more than one carbonyl group, that is two aldehydes or two ketones, one aldehyde and one ketone at 1,6 or 1,7 positions with respect to each other and containing alpha hydrogen atom, when treated with dilute base, undergo aldol condensation in an intramolecular fashion to form cyclic products. Now let us take one example. This is hexane 1,6 diol. 1, 2, 3, 4, 5, 6. Hexane 1,6 diol. So when this compound is treated with dilute sodium hydroxide, okay, the base abstracts alpha hydrogen atom. Let us suppose from this carbon atom alpha hydrogen atom is lost. So what will I get? This carbon atom, that is fifth carbon atom, now attacks the first carbon atom. The fifth carbon atom now attacks the first carbon atom. So what will I get? I will get the anion of aldol. Okay, anion of aldol. This anion of aldol will get protonated. To form aldol. Okay, this aldol when heated loses a molecule of water. This aldol on heating loses a molecule of water. So what will I get? CH2, CH, CH2C, CH4 and double bond here. Cyclopentene 1 in carbaldehyde. This is this product, cyclopentene 1 in carbaldehyde. This reaction is intramolecular aldol condensation. Okay, in this reaction, first an aldol is formed, which subsequently loses one molecule of water to form alpha beta unsaturated aldehyde or ketone. In this case, we are getting alpha beta unsaturated aldehyde. What is the driving force for this elimination of water? It is the stability achieved by conjugation of double bond with carbonyl group. So this aldehyde and double bond are in conjugation with each other. So it's more stable. So the driving force for elimination of water is stability achieved by conjugation of double bond with carbonyl compound. This is intramolecular aldol condensation.